Hi guys, it's me, Abdul Karim. This time I want to explain about nonlinear equations. Nonlinear equations can be interpreted as equations that do not contain conditions such as linear equations. So nonlinear equations can be equations that have powers other than 1, for example x squared, and equations that have the product of two variables, for example xy. In nonlinear equations, there are three subjects that will be discussed. First is quadratic function. A quadratic function is a function that has an equation in the following form: y equals ax squared plus bx plus c, where a, b, and c are real numbers and a is not equal to 0. But as you can expect linear graphs to look like this one right over here, you can expect quadratic function to look more like a u. One other way to refer to the graph that represents a quadratic function is parabola. Now, depending on the exact equation, a parabola can either be pointing up or down, and it can be either wide or narrow. And of course, it doesn't need to necessarily have to start right at the origin. It can start at anywhere else as well. First thing first, let's take an example from this form that y equals to ax squared plus bx plus c, where a is equal to 1 and b and c are both equal to 0. What we get is y equals x squared, and the graph will look something like this. Well, if you plug in the numbers for x, you would get this particular graph. If you plug in 0 for x, you'd get 0 for y. If you plug in 1, you'd get 1 for y. If you plug in 2, you'd get 4 for y, and so on and so forth. The next is exponential function. The exponential function is the mapping of real numbers x to a in general form fx equals to a the exponent x. In an exponential function, however, the x value is the exponent itself. An example of an exponential function would be y equals to the exponent x. As you can see, if x is 0, y is 1. If x is 1, y is 2. If x is 2, y is 4, and so on and so forth. Notice how as x increases, the increase in y itself becomes greater and greater. This is one of the things about exponential function, in that the graph increases at an increasing rate. An exponential function can never equal 0. Even we did 2 to the exponent of negative 100, we would end up with 1 over 2 the exponent 100, which is a very, very small number, getting very close to 0, but still never actually touching 0. Here's an example of a generic exponential function now. If a greater than 0 and b was greater than 1, then we can expect that graph to look something like this. If a greater than 0 and b is greater than 0 but less than 1, then the graph will look something like this. Now, if less than 0 and b was greater than 1, then we can expect the graph will look something like this. And if a is less than 0 and b is greater than 0 but less than 1, then the graph will look something like this. Great. So that's it for introduction to exponential function. Last is logarithm and natural logarithm function. Logarithms are mathematical operations that are the reciprocal of exponents. If y equals a the exponent x, where a bigger than 0 and a is not equal to 1, is an exponential function with the base number a. Then the inverse function is written as y equals to a log x. To graph a logarithmic function, for example, y equals to a log x, we first convert y equals a log x to its exponential form, namely a the exponent y equals to x. Example, if y equals to 2 log x, it becomes x equals to 2 the exponent y. So we can make a table like this. If y is negative 3, x is 1 over 8. If y is negative 2, y is 1 over 4. And if y is negative 1, x is a half, and so on and so forth. So the graph will look something like this. The natural logarithms is the logarithm based on a, where a is 2.718 and so on. The natural logarithm is defined for all positive real numbers x and can also be defined as for complex numbers that are not zero. Natural logarithms functions are defined with this. So, the notation for a natural logarithm is in x. Based on the above definition too, you can understand that in x bigger than 0 when x bigger than 0, in x less than 0 when x bigger than 0 but less than 1, in x equals to 0 when x equals to 1. For example, y equals to in a. The logarithmic function can be described using the vertical asymptote at x equals to 0. And the points is 1 in x, 2 in x, 3 in x, and so on and so forth. And the graph will look something like this. Okay, that's it for my explanation about nonlinear equations. See you next in the next video.